So let's talk about a couple of things and then talk about the exam. First of all, hopefully you saw this. I posted this yesterday, I believe. Um, they sent out a questionnaire um, for Grace, which is our ACM chapter here on campus. It's really a women's-led chapter, but it's open to everybody. In fact, I'd encourage all computer science students to take advantage of Grace. One issue I think they've had this past year is that the meeting time is a little bit incompatible with a lot of people's time schedules. So they're looking for potential other meeting times so that we can get more involvement. This survey also gets into kind of what you would like to see happen with Grace in terms of the type of events they do, the types of things they do at the meetings, that kind of stuff that would best serve you. ACM groups are, I think, a really important part of computer science, and they've been around for years and years. And at the University of Illinois, I was a member of their ACM chapter, and I mean, every meeting had like 140 people at it. I mean, it's I don't know. I find it kind of sad when we look at the attendance at our thing. Obviously, we don't have a program the size of University of Illinois, but I mean, what that group can be relative to what it currently is it has a lot of room to grow. So I'd like to see as many computer science students as possible participate in this survey and kind of get your thoughts out there. So hopefully we can schedule it such that more people will show up and take advantage of some of these extracurricular activities. And just to put just a general plug, I mean, the extracurricular activities is really what makes your college education special. I mean, you're only going to get so much out of the classroom. You go up, go through the motions. The classrooms are kind of geared at your average student that's in there. So if you have aspirations or are interested in topics that are beyond what are being thrown across your bow in terms of traditional computer science education, then you really need to go outside the classroom and look at some of these groups like this, or get involved in some research with faculty members, that kind of stuff, and kind of, or get involved with these hackathons. Get your money's worth, if you will, so that you leave college with some skills that are beyond what you're just going to get in the classroom, which is going to be more of a theory-based thing. So strongly encourage you to take advantage of extracurricular stuff related to your education and not just let the classroom experience be enough. Okay, and if you fill this thing out, you have a chance to win some gift cards. I don't know if they're gas gift cards or just gift cards or whatever. There's a chance to win big prizes. So please fill that out if you would. Secondarily, I put this up last week, extra credit opportunity. This is for tomorrow. There are no classes on campus tomorrow, but there will be a lot happening on campus tomorrow. There is it's our 500-year Reformation for the Lutheran Church. So whether you are Lutheran or not, or whether you're Christian or not, I think this is going to be a good educational experience. There's going to be lots of different talks, and so I've given you 3 different opportunities for extra credit. So there's a keynote that's in the morning, and then in the afternoon there are kind of like 5 or 6 different talks, and they're repeated. So there's like a session 1 and a session 2. So if you attend session 1 and or session 2, each of those things for up to 3 will get you like a token, and these tokens are worth either a free quiz, a free homework assignment, or a 5% extra credit on an exam. So they're like redeemable vouchers, if you will. For each one you attend, you have to write a 1-page summary of how it relates to your major, what you learned from it, that kind of thing. So if you go to 3, I should get three pages from you emailed to me. Make sure you let me know which class this is for, because if you are, or classes that this is for, if you're in more than one of my classes, then you can double dip. So if you attend 3, then you'll get 6 tokens, 3 in each of those classes. Okay, so more classes you have of mine, the better deal it is. But I would encourage you to go even if you weren't getting extra credit. I think it'll.
Use those tokens on the final exam.
Yeah.
Okay.
You get to use them whenever you tell me you want to use them. So you email me or something and say I want to use token on homework number 7, and then I'll replace whatever grade you got on homework number 7 with 100, and then we'll burn a token.
And when should we have those papers turned in?
Let's say end of day Monday or something. Soon.
Soon, yeah.
Yeah. I don't necessarily.
Not a hard deadline.
Yeah, I don't necessarily care. I mean, let's say no later than next Wednesday.
All right.
That way, I'm still in the role of getting stuff put into the book into the token category. I don't want them trickling in a month.
I don't want the final exam rolling in.
And then all of a sudden, I'm getting these papers. Yeah. So, anyways, the keynote is in the morning. There's a breakfast, and I've tried to research this some. At 8:30, it says coffee and community breakfast. It's unclear to me whether this is complimentary or not. It should be. It better be. But it's unclear whether it is. I don't want to false advertise it. I believe it probably will be free, but I'm not 100% positive. I'm very food-centric, so the highlights are the meals. Then chapel at 9:30. I'm not giving you extra credit for it, but I'd encourage you to attend. Dr. Ferry will be speaking, so he usually gives a pretty good talk. 10:30 is the keynote, so this is your first extra credit opportunity, Delio. Talking about vocation, and obviously something I mentioned in your one-page things you need to send me is how this relates to your major, your career, that kind of stuff. So this should be a pretty easy connection. He's going to be talking about a Christ-centered world and your vocation. So this should be a pretty easy opportunity to get the extra credit. It shouldn't be too hard to write something up related to vocation since it is on vocation. Noon, there's a lunch. Again, I assume this is included, but haven't gotten an official word. In the afternoon at 1:30, there's a panel discussion. This is kind of, I think, something to ask questions about the morning keynote. I'm not overly excited about this one. So, I don't know. My experience has been that usually panel discussions end up just being this kind of flop thing. But if you're into that, show up to that one. I'm not pushing that too hard. Now, so in the afternoon, starting at 2:45 is that first sectional thing, and then I think starting at 4 is the second one. There's a break at 3:45, so it looks like each one's an hour. So it's an hour-long talk. I read these this morning. I'll just kind of summarize them this time around. So you can attend one of these several different things, and they're repeated. So you can go to the earlier one at 2:45, or you go to the later one at 4 o'clock. You can go up to 2 of these, and so you get extra credit for each one you go to. You do not have to go to Dr. Locklear's. You can go to any of these that are of interest to you. But to get extra credit, you have to go to 2 different ones. So in any case, Dr. Locklear will be giving a talk it's from Martin to Motherboards, Technological Artistry in the Wake of the Reformation. So obviously this one should be pretty easy to connect to computer science, since that's going to be the direction it's coming from or the angle it's coming from. So certainly encourage you to check that one out. But like I said, you're not required. Next one is by Dr. Brad Condy, Business and Vocation, Having Jesus as Your Customer. I'm personally kind of interested in that. I was mentioning this morning when we were talking about this. Dr. Condy actually teaches marketing. And he's in the business school, and it's kind of an interesting thing. I'd like to know his approach on, kind of treating your customers as if they're Jesus. Well, I mean, would you charge Jesus? Probably not. So all of a sudden now you're like a vagrant. You're not making any money, and then stuff like that. So it'll be interesting to see the kind of the twist on that, kind of thinking about business through maybe a Christian-centric lens, which I maybe find interesting just from the perspective that I think when you start thinking about business and the art of the deal and stuff like that, that starts sending you down a path that maybe isn't necessarily compatible with a Christian worldview. So should be an interesting type thing. Next one, Brad Alice, Reformation in Jeopardy. My understanding from reading this, it's kind of learn about the Reformation, learn about the things that occurred 500 years ago in the context of the game Jeopardy. I think that's kind of how it's going to be. So if you're kind of trying to figure out why you're there, that kind of stuff, or what this whole Reformation thing is all about, that might be a good one to attend. At that point, when you write your one-page paper, you might have to make some sort of weird connection, like kind of how does the Reformation of Lutheran Church kind of connect to your vocation today? What things did they do? Because at that point, you got to start tackling some of the topics like the various denominations of Christianity and things like that, where it's maybe one of the problems with organized religion is nobody can agree with each other. But in any case, it's should be an interesting thing at the very least. But it might be a little bit more difficult to write that one-page thing. But I'm not going to be overly picky. I just want you to at least contemplate how it connects to your degree. Let's see. Job search. Think of vocation as worship. So is this is all in the same. So this is looking at jobs, and there's a couple of different speakers, it looks like. So we have health professions, nursing, pharmacy. Pharmacy is its own program, it looks like. So it looks like kind of a health professions and nursing talk here. I guess finding jobs. This one's in. This kind of gets confusing in how it's written. I think these are separate. So this is one. So it's a job search. Think of vocation as worship. I don't know who's giving that talk. Then in the Todd Weir Theater, you have health professions talk. And I guess same place is a second talk, so maybe they're splitting up the time. Then we have a pharmacy, applying spiritual history in patient care. That one actually looked kind of interesting to me. Maybe not as specifically from a pharmacy perspective, but they talk about in here how a patient's spirituality plays into their recovery and the process of talking to patients about their spiritual history, like kind of figuring out what their background is, without like shoving it down their throat, because that's always a challenge, I think, as a Christian when you're trying to talk to other folks at stuff. You don't want to maybe come off as the Bible thumper, walk up and smack them in the face with a Bible. I want to talk to you about Jesus, and that doesn't always start off the conversation on the right foot. They think you're a wacko. So that might be kind of interesting just from that perspective, I think, for me. So I'll probably go to that one, and I'll probably maybe also go to the Jesus as your customer one. Those are my two leading ones right now. So if you're wanting to make sure I see you, come to one of those two. If you want to avoid me, don't come to either of those. So you kind of choose on, you pick your poison, I suppose. All right, questions about the extra credit opportunity. And this is tomorrow here on campus. Okay, so now let's talk about the exam. So our exam will be on Thursday here in the classroom. You'll have the full hour and 15 minutes to take the exam. There'll be 10 questions. Most of my exams are 10 questions. It'll be all short answer. programming essay type things. I don't ask multiple choice. I don't ask fill in the blank or true false. So they'll all follow that format. A good percentage of the exam is going to be programming to some extent. We'll talk about that as we go through these topics. Do remember that the way we have two exams in here. We have a midterm and a final, and the way I handle the exams, I think each one's worth 20% of your grade. But I have a policy that if you suck on the midterm and you do better on the final, I'll replace your midterm exam grade with your final exam grade. So you get two shots at the midterm, if you will. So hopefully you can use the midterm as at least a litmus test to show you where you currently stand relative to where you probably should stand in terms of your understanding of the class up to this point, and you know whether or not you're on you're keeping up with class, or if you have some stuff you need to catch up with. But definitely take advantage of those extra credit opportunities. All right, so I'm going to kind of go through the slides we talked about so far this semester and indicate the areas that I think are most important. Remember early on we kind of reviewed some of the stuff from last semester, so I probably would not ask too many questions from these. They would be fair game, but I would say low priority. I would have to be looking for like a filler type question. So the idea that Java is platform independent, the difference between C# and Java, important concepts probably are not going to make the exam. The nature of a CPU being a collection of magic tricks, probably nothing specific about the CPU. This idea of how humans solve problems, that's going to make its way onto the exam in one form or another. So do understand this idea of memory asking questions and repetition and how that maps over to our computer programming languages. It might not come in a real clear format like this, like how do humans solve problems, but certainly could be a question like by what mechanism are each of these emulated in modern programming languages. So memory would be through variables, asking questions would be through conditionals, and repetition would be through loops and functions. This idea of loosely typed versus strongly typed languages, I can see that being on the exam in some format because that kind of represents the transition from last semester to this semester, where we looked at Python, a loosely typed language last semester, and now we're looking at we're working in Java, which is a strongly typed language this semester. What's the difference between a loosely typed and a strongly typed language? Yeah, so strongly typed, when you create a variable, you have to say what kind of value it's built to hold, an int, a char, a string, whatever. In a loosely typed language like Python, you define a variable as a bucket for holding stuff, but you're not saying what kind of stuff ends up going in there. What are pros and cons? Loosely typed language, what's good about a loosely typed language? And similarly, what's bad about a loosely typed language? Nothing? Loosely typed languages are relatively slower. Why is that? Okay, because we need something that lives on top, like a type inference engine that has to figure out what kind of element lives inside of a variable before it allows you to do stuff to it, because you haven't specifically labeled it as being of a certain kind of value. All right, so loosely typed languages, they're slower because of that type inference engine thing. So typically we think of slow as being bad. So then what's good about loosely typed languages? We worked with Python last semester, and Python was, we didn't just pick it out of the sky. It's a pretty popular language. You can go and find a lot of jobs in Python today. So what's the advantage of a loosely typed language like Python? How many of you found Python last semester easier than Java this semester? I would say that's a fairly common opinion. I don't necessarily view it that cleanly, but I mean, I'm pretty far removed from originally learning this stuff. So, but the general acceptance is that loosely typed languages are easier to learn. There's less kind of structured, important stuff. Things that just have to be there. There's less fluff, if you will. I mean, really, the only really important thing with Python is the indentation aspect of it, right? Where things have to be indented to show that it belongs to the guy above it. But other than that, it doesn't force you into having a lot of these extra steps that you have to think about when you're writing your code. What kind of variable will this hold and that kind of stuff. So generally speaking, loosely typed languages are easier to learn. Conversely, strongly typed languages tend to be faster. Now, I don't necessarily like thinking about loosely typed or strongly typed languages being harder to learn. But with that increase in speed comes that maybe an increase in responsibility. We have to do a little bit more upfront programming because we're not relying on the language under the hood to do as much for us in terms of figuring out what we meant. We have to be more explicit about what we mean as we're writing it. Okay, so certainly be able to write variables in Java. There will certainly be some programming questions, and that'll come in that format where it'll be asking you to define a variable for holding some kind of value. Maybe define an array capable of holding 20 elements and fill it up with random numbers, something like that. That would be a fair type of question to ask. So make sure you're comfortable defining variables. So we have the type followed by the name equals the value. I wouldn't ask you to regurgitate this list like this, but I certainly could ask you questions. A question I typically like asking, whether it makes the exam or not is a whole different story, but something along the lines of why do we have so many different ways of holding signed whole numbers? So bytes, shorts, ints, and longs, they all hold signed integers, positive and negative integers of different sizes. Why is it that we have so many ways of holding the same kind of values? Okay, but we don't really care about that now, right? So this is more of a historical leftover where when Java, or when the grandparent language, C, came out in the late 60s, bytes, shorts, ints, longs existed because memory was at a premium. We needed to be very careful about how much memory we used for different things. So back then, if you only needed to hold a relatively small integer inside of a variable, you might choose a byte because that's going to take up less memory because memory was at a premium. Today, we got memory out the wazoo. So, we don't necessarily care about that so much today. You will still see bytes as it relates to maybe like video streaming or something like that, where the data happens to show up in a bite-sized format. So that's just the most convenient way to digest the information. You'll rarely, if ever, see a short in modern programming. You mostly see ints, and every now and then you'll see a long if you need to hold a really big number. All right, so I won't ask you questions about the specifically the number of bits, things like that, 8 bits, 16 bits, 32 bits. But as you know, I do like conversion questions, so I'd be surprised if there wasn't at least one conversion question on the exam going from one base to another base. Okay, those should be free points on exams, and it's shocking how often they're not free points. I mean, this is the same thing as our computer science get-together where you just know for a fact they're going to ask you the Concordia, what's it called? The mission statement, yeah. So that is on there every single year. So if you want one of the better prizes, memorize that and show up and get ready to put your hand up quickly. Okay? It's on there every year. So make sure you know how to convert between a base and decimal a decimal to any base, because I like asking questions about those. All right? Practice it. It will be a free 10 points on the exam if you know how to do that. In fact, if I start running low on questions, it might be a free 20 points on the exam. I might ask 2. Okay, don't be that person that loses 20 points in the exam for a question that should not be difficult. All right. But related to our primitive types, I'm not going to ask you to, how many bits is a double before and after the decimal point or something like that. I kind of expect you to have a general understanding that, bytes are smaller than shorts, or smaller than ints, or smaller than longs, and you probably should be able to come up with this 8, 16, 32, 64-bit thing, but I wouldn't ask you to. I'm just kind of telling you that you probably should have at least general feeling that those are your options. They start at 8 bits and they kind of go up to 64 for right now. Certainly understand the concept of the Unicode character set, how that relates to chars. I could definitely ask a question related to doing math with chars or something like that. Maybe I show you a couple of lines of code where I create a char, I add some number to it and ask you what the result will be if I print it out. That would be fair game. Questions like, what's the output of this code? I wouldn't ask you to memorize this number, even though most of you should be familiar enough with the 65,535 number to be able to come up with, at the very least, something like, isn't there 60,000-ish characters, something like that? Or if you want to be accurate, you can say 2 to the 16th power, 0 to 2 to the 16th minus 1. But I wouldn't ask you for this exact value. Let's see. The concept of all programs begin and end with main. I wouldn't ask it directly like this, but it would be fair game for me to show you a full program and ask you what the output of this program is. Where I might show you 3 or 4 functions in there, but I may only call one of those functions from within main. So you have to show me that you understand that main drives that program. So just because you've written 20 functions doesn't mean you're ever calling those functions. The concept of a pointer and how that relates to Java. So maybe a question along the lines of, it's often, or many books indicate that pointers do not exist in Java. That's not the truth. What is the truth related to pointers in Java? So how are pointers represented in Java? Or when a book says that pointers don't exist in Java, what are they really saying?
The programmer can't use them. Well, there's no syntax.
Yeah, that's the more accurate thing to say. There isn't a specific syntax for us to say whether I want the memory address associated with something or the something itself, the actual value. Okay, that's what a pointer is, a bucket for holding a memory address, and Java doesn't have that defining syntax for us to say I want the memory address or I want the value. You get what you get. Okay, and the point is that I guess pun intended, pointers do exist in Java because pretty often we actually get memory addresses. That's what we get. All of our object types minus strings. We know strings are actually stored as memory addresses, but because they're kind of treated like primitives, they're not exposed through a memory address. So we get a lot of memory addresses with arrays and with objects and things like that. And you mentioned that we can't use them, but we actually can. How could we use a pointer in Java?
Besides with the comparing to say 2 objects of the same memory address.
Yeah. So, we can use them with the equivalence operator. A pointer is a primitive type. So I can ask, is this object the same object as this object? Not do they look the same. This kind of gets back to that comparison of strings, which I certainly would, if I remember, I probably will ask a question about that one. So on the same subject, if I say something like, string s is equal to hello, string s2 is equal to hello, string S3 is equal to new string hello, I might ask you, what's the output of these two lines going to be? S equivalent to S2 would give me a what? A true. S equivalent to S3 would give me a what? False. And then the follow-up question is why? Is S equal S2 saying, well, hello equals hello? That's not what it's actually comparing. It's not looking at the contents. It's looking at the memory address. And because I use this special format that Java provides us for creating strings, I call this like syntactic sugar. It initially created the string hello literal and loaded it into memory here. But then when we set S2 equal to the string hello literal, it noticed that we already had that guy stored. So it just assigned S2 the same memory address as S. So they would both point to that same literal rather than creating the literal multiple times. But down here, because I specifically use the new keyword, this dictates I want to create a brand new string that happens to be the same as my old string literal, but because I said new, I want it to be new. Make sense? So understand that the equivalence operator here is not comparing the contents of these strings, because this is for primitive types. This is comparing the memory address of S to the memory address of S2, and they both point to the same place because they both point to the identical string literal. Whereas S3 actually points to a new memory location because I specifically asked for a new memory location to build that guy in. Make sense? So that's a working example of this idea of pointers and using pointers. So something like that would certainly be fair game on the exam. Make sure you understand that double equal sign is dangerous for comparing strings. So here's an example of a conversion question. Certainly you should be able to convert a decimal number to a binary number, or a decimal to octal, or hexadecimal to octal, any way. Should be able to go from all sorts of different values. Yeah. Yeah, you can use a calculator if you bring your cell phone with you and you want to use the calculator in your cell phone, that's fine. Just don't use it for anything other than that. Don't Google stuff, and don't Google what's 236 in hex or something like that. Do the math. Just don't cheat. Certainly the plus, plus, minus, minus operator, understanding the difference between those, I would say a little bit lower priority on the exam. That probably wouldn't be one of the first questions I'd ask, but if I'm looking for a filler question, I certainly could give you a couple of lines of code and ask you what the different output might be. If I say, int I equals 5, and then I print out I plus plus, and then I print out plus plus I, what's the difference going to be? Something along those lines. Syntax for if statements, wouldn't ask you it directly, but obviously you should be able to write if statements in the context of some code. What's a Boolean expression? Again, probably wouldn't ask it directly, but you should certainly be comfortable with Boolean expressions. Same thing with loops. It might be a fair question to ask the difference between a pre-check and a post-check loop for for loops and while loops versus do while loops. Not the highest thing on my priority list, but that would probably be in a similar ballpark to like plus, plus, minus, minus. Certainly be able to write functions. Most of the programming questions on the exam will probably be write a function that does something, write a method that does something, as opposed to writing an entire program. One question that I do like asking on exams that, if I think about it, will probably make it onto this exam, will be like write a error-free hello world program, the full program. So that's kind of one of those things I tell students they should memorize how to write. That way they always can, when they start writing something in Java, they can just start with a blank template And if as long as that works, you know you have a working Java program you can put the rest of your logic into. So be able to write an error-free hello world program. So that would be like public class hello, opening curly brace, public static void main, string array args, open curly brace, system out dot println hello world, closing curly brace, closing curly brace. The whole rigmarole. Certainly the idea of a class, that it's a collection of fields, methods, and constructors. Know what a field is, know what a method is, know what a constructor is, and when we would use those different things. Be able to identify fields, methods, and constructors by looking at their definitions, as well as looking at them being used in the wild. All right, so if I show you some code and I say something like, s dot some function name, and I ask you what that function name must be, so I say something like s.lol, something like that. I ask you what kind of animal this guy is. You would say, well, it's a method or a function. Takes no parameters. How do you know it's a function? It has open and closing parentheses. Is it an instance function or is it a class function? Probably an instance function, because I'm calling it with what appears to be an instance of something instead of a class name. Okay, so certainly understand those concepts. How do you call class methods? How do you call instance methods? How do you write class methods? How do you write instance methods? When would you write a class method? When would you write an instance method? Again, those should be free points. Think about how many times in class I've asked, what kind of method is this? How do you call it? Class methods you call using the name of the class in which the method was defined. Instance methods we call using an instance of the class in which the method was defined. How do you write class methods? We write class methods using putting the keyword static in front of the method name. How do we write instance methods? We don't put the keyword static in front of the method name. Those should all be free points. So don't be the person that misses 10 or 20 or 30 points because you don't understand the difference between class methods and instance methods. Also understand the rules related to constructors. Constructors must match the name of the file, the name of the Java file, identically, the name of the class. So if you have a class called superstring, the constructor would also be called superstring with the same capitalization. And what's the return type for all constructors? A little bit of a trick question. There is none. Constructors don't have return types. Methods have return types. Constructors don't. Why? Okay. Aren't constructors always called after a certain keyword? What keyword always comes immediately before calling a constructor? Nope. We had an example. Well, here. Random R. My constructor for random looks like this. What comes immediately before that constructor? New. So the call to the constructor always comes after the new keyword. So what's the return type of any constructor? A memory address. So why say what you're going to return when what you return is always, always, always the same thing? It's always a memory address. And specifically, Java doesn't give us a syntax for saying we're going to return a memory address, so we couldn't do it even if we wanted to. All right, so constructors always return a memory address because they're always called in conjunction with the new keyword. Therefore, in Java, we don't actually write a return type for constructors. We leave it blank. It's not void, it's just omitted. Make sense? Now, I'm guessing that some of these things like this are kind of the reasons why you find Java more difficult than Python, like these little details. Okay, so the details are important. One good thing that I can promise you, because I have mentioned that programming is programming, that once you understand the details in one high-level language, those translate pretty cleanly over to other high-level languages. So when you go and you start working in C# next semester in, well, we'll be working in Java in 300, but in 370, which is the software engineering class, you'll be using Visual Studio and C#. You'll notice that Java and C# real similar. All right, so, and you won't have to like relearn a lot of these rules because they pretty much slide right on over. Okay, so you don't have to worry about that difference between Python and Java being the same difference for every language you learn. It's really more of a loosely typed versus strongly typed language argument, which is also the same argument as interpreted language versus compiled language argument. Those are the same things. Certainly be comfortable with the mod operator. I might ask you a question that will require you to use it, or show you some code that will require you to understand the difference. This is the remainder of integer division, so the remainder for long division. Be able to write Boolean expressions with ands and ors, all that jazz. Fair game to ask the difference between a single pass and a multi-pass compiler, but would be pretty low on my list. You know, you should understand that concept, but that's more of a computer programming history type question. I would need to be fairly desperate for a question, and I think I would pick other questions first. So you can roll the dice on that if you want, but I would say there's a pretty low chance that I would ask a question about single pass versus multi-pass compilers. So now, as a joke, what I'll do, the first 3 questions on the exam will be about the compiler types. All right, again, static versus non-static, that whole world involving class methods versus instance methods, or class fields versus instance fields, how you call them, how you write them, when would you write one versus when would you not. Similar thing, XML versus JSON. I would need to be, desperate for a question. Probably a short question. Programming questions, I have to kind of factor in some time, how long I think it's going to take you to write it. Where if I need kind of a throwaway question that I expect you to be able to answer in a minute or something like that, it would be a question in this ballpark. I would probably ask an XML or a JSON question before I asked a question about the different kinds of compilers, if you're looking for a pecking order there. But I would still say XML, JSON. You should know what they are, but probably a relatively low priority type question. I don't think I don't plan on asking one of those. Certainly know the definition of a primitive type. I don't know if I'll ask it directly, but you should understand the difference between primitive types and object types. Certainly as it relates to pass by value versus pass by reference. So those are other concepts that are important. Actually, this quiz question here is pretty related to that whole idea of understanding class methods versus instance methods and why we would use them. So I mentioned something. Why does the character class exist? Why does it? Why do we have the character class in the first place? And I could replace that with why do we have a class called Boolean, or a class called integer, or a class called long? No. There is a class called character with a capital C in Java. Why do we have it? We do stuff with chars. Because chars can't do stuff themselves. Because chars can only hold a value. So all of our primitive types are very, very limited on what they can do. That is, they can hold a value. So if we want to be able to operate on our primitive types, do things that are beyond that, convert it to uppercase, convert it to lowercase, ask if it's a digit, things like that, we need some classes, some things built into Java that might be helpful for that. All right, so that's why the character class exists, so that we can do stuff related to chars. Why is it filled up with static methods instead of instance methods? when would you create an instance of something? So for instance, with the string class, we create multiple instances of strings, right? We have string s equals hello, string s2 equals world, because we want to hold different contents, right? And then strings can also do things to themselves. With chars, though, in this example, a char, we already have the ability to hold a value, don't we? The char primitive type knows how to hold the value. We don't need a new way of holding chars. We just need something that allows us to manipulate a char or to ask questions about chars. So really, we don't need an instance of the character class for every single char that we ever create. We really just kind of need a factory. Okay, so I need this character class, and I drop a char into the top of it, and it gives me an answer on the bottom, right? And I can use this guy over and over and over again, right? We don't need a new toaster for every bag of bread we buy. We have a toaster at the house, and we throw toast into it, right? Because we already have a way of representing toast. We just need a way of toasting it. Make sense? So character class is kind of like our toaster. It exists so we can do things to toast, so we can do things to chars, but we don't need a new copy of it. We don't need a toaster for every piece of toast we ever want to toast. We perform it on chars. The character classes perform stuff on our char primitive type. The integer class performs stuff on the int primitive type, so on and so forth. Okay, and that's why it's filled up with static methods, because those methods only exist once. Because it's a factory. It's made to exist once. It's made for us to pass stuff into for it to operate on, and it spits the answer back out. It's also why class methods typically take in at least one parameter, because they don't know about the value that the object that they're written inside of holds. They don't have that knowledge. So the character class doesn't know what char you're operating on unless you hand it to it, because it's not an instance. Okay, certainly all the stuff with strings. Strings will be represented on the exam significantly. So most, several programming questions, whether it's reading code or writing code or, reversing a string or removing some characters from a string or adding some characters to a string, whatever it is, understand the nature of strings. So the whole double quote stuff followed by 0 or more characters. So the empty string is double quote with no characters. Empty string ends up being kind of a building block for building new strings, that kind of stuff. Strings are read-only, so if we need to change something in a string, we have to build a brand new string, that kind of stuff. The idea of concatenation, certainly understand that. Again, instance methods, how you call them, how you define them, how you identify them. And I really want to drive this home. Instance, calling, defining, these different things, they're going to be on the exam in some form. If for no other reason, your evidence is how often I ask about that in class. It is such an important concept, and it's a concept that too many students don't commit to memory. And it unlocks a huge portion of a language to you just by reading the documentation. If you just have it clear in your mind how these things work, you can read the documentation easily. So if you do nothing else, study the instance methods versus class methods. How do you identify them? How do you call them? And you'll probably pull a 30 or 40% of the exam just from that concept. Make sense? Can't stress that enough. So then, in the string class, a couple of our go-to methods, so kind of recognize what your toolbox looks like for the exam. So kind of our two pretty powerful methods we've used in conjunction with each other this semester with the string class have been the char at and the index of methods, which are kind of inverses of each other. So, any question involving strings, you might ask yourself if those guys might be helpful. So understand what index of does. Index of returns the position, the integer-based position of the first occurrence of a char inside of a string, or a -1 if it's not found. And that -1 thing is typically the powerful side of it, right? Otherwise, it's just searching a string for something. But that -1 thing says, is the thing I'm searching for not there? That's pretty handy pretty often if you're looking for things that are like vowels or consonants or numbers, that kind of stuff. Understand the way you actually compare strings. So we don't use the double equal sign for strings because strings are object types, and if we use the double equal sign, we're actually comparing the memory address of the strings rather than the contents of the strings themselves. So we would use the equals instance method of the string class for comparing two strings to each other. There's also one called equals ignore case. I mean, you should know that that kind of exists, but I'm not going to ask you a question specifically about it. Similarly, if I've asked you to write some code where you have to use equals, and you know it technically should have been case sensitive, but you didn't write it in a case sensitive way, I'm not going to take points off. I'm looking for competence, not those stupid little details that you would have caught when you're writing it on the compiler. You know, if you write everything else right in a question, you forget one semicolon, I probably won't take anything off. If your entire exam omits semicolons, then you're ready to start losing some points. But, you know, one little missed thing like that, not the end of the world, except on a question like write a perfect hello world program. So that question would be graded in binary. It's either perfect or you lose all points. So commit working hello world program to memory. And you can test yourself pretty easily by sitting down in front of Eclipse with a blank screen and typing in what you think is a hello world program and then hitting play. And if you can do that 3 times in a row without making a mistake, you probably got it. Make sense?
Worst case scenario, it has a thing in there that a step-by-step process.
That's fine.
If you just want
Yeah, but that's not going to help you on the exam.
No. Well, if you follow the steps and you memorize the steps.
Yeah. But I mean, there's not much to it. Yeah, but just that should be something that's just in your brain. And really that's true for most programming languages. If you can just memorize how do you write a hello world program in that language, then as soon as you're asked to do something in that language, you can just start with that template. And then you have a starting point for any language. So that would be the only kind of question that would be, explicit. You can't make a mistake. So be very, very, very cautious with the hello world one. Otherwise, I'm not going to get too bent out of shape over like you misspell the word equals or something like that. It's pretty clear when you're grading programming stuff whether the person who wrote this pretty much knows what they're doing or is completely clueless. There very rarely is situations in the middle. And if you are a situation in the middle, then you're probably a couple of weeks from really catching on then, which is unfortunate for the timing of the exam, but probably good for the timing of the final exam. Usually it's either you just can't write a for loop to save your life, or you're pretty good. You usually have a couple of errors when you first type the stuff in, but you can pretty quickly fix it. And then it's more of the struggle of kind of coming up with a logic solution to a problem rather than the syntax itself. Certainly understand the new keyword. We've already talked about that. Understand the this keyword, how an object refers to itself from within itself. It's an important concept. Similarly, the super keyword probably would not ask you questions about the super keyword on this exam, but it'll be represented significantly on the final, because we're just starting to kind of transition into that inheritance thing. So you should certainly understand inheritance, but I probably won't ask you to write a lot of stuff related to it. Certainly arrays, be able to define an array, be able to work with arrays, be able to manipulate arrays, things like that. Understand that arrays are passed by address, not passed by value, so making changes to an array have a permanent effect. You should certainly understand how arrays are actually built in memory. When I say arrays are represented in contiguous memory, what does that mean? If I were to ask that question on the exam, what does it mean when I say arrays are implemented using contiguous memory?
They're all in order, like it's all together.
Yeah, it's back to back. The buckets of an array, if you have a 10 bucket integer array, those 10 buckets are stored right next to each other in memory. So we have an int followed by another int followed by another int, and that's what makes arrays fast, because we can compute the location of a specific element in the array. So arrays are fast, they're memory inefficient, because when you build an array, if you're not sure how many things you need to hold, you just, build an array with 100,000 buckets. Well, you only put 3 things in there. Yeah, but I got enough space for 100,000 buckets. Same exact thing that happens when somebody buys too much house. And they got to decide how to fill up all the rooms. And then 10 years later, they decide that they need to figure out how to get all the crap out of all the extra rooms. It's
Even worse than they're forced into a smaller house before they can get rid of all the
yeah. And then it's funny when you see somebody who went into a smaller house, then goes back to a bigger house. And they're like bouncing back and forth between stuff and no stuff.
Yeah.
And a microcosm also, people who have pets and then get rid of pets and then years later get pets again. They have to rebuy all their old pet stuff that they gave away. And my wife wants to get cats again. That's not happening. 14 years of 3 cats. We're done. Plus, we have no more cat stuff. Gave it all away. All right. So be comfortable with arrays. Be comfortable with the concept of inheritance, specifically related to that toString method. I think that toString method will probably find its way onto the exam in one form or another. How's the toString method used? When I say the toString method that's built into the object class, what's the significance of that toString method built into the object class? Just an exhilarating group today. Has to do with the println method. How many different versions of systemed.out.println are there? Several, right? There's a println that knows how to print an int, a byte, a short, a long, all of our primitive types. Then we have a println method that, if you remember, knew how to print a char array. Okay. We have a println method that knows how to print a string. And then we have a catch-all. What's the catch-all println method know how to print? We have one final println method, because obviously the makers of Java didn't know that we were going to at some point write a superstring class. They couldn't have made that guess early on, right? So we have a final version of println that takes what kind of parameter and prints it out? It takes an object. So it needs to know how to print out any object. So when it gets an object, when it gets something that's not an int, not a char, not a blah, 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 not a string, it must be an object. What does it try to do with that object? That's what it does. It prints its memory address. And how did it ultimately print its memory address? What did it do to that object to ultimately print its memory address? In the context of the question I'm asking here about the toString method, perhaps it calls the toString method of the object class. So the object class has a toString method that the generic form of that returns a string that is a memory address representation of that generic object. That way we guarantee that every single object knows how to print itself, even if it just prints out the weird memory address. But that also means that if we write our own object, for instance, superstring, we could override that toString method and teach it how to print out the contents of a superstring rather than that default memory address. Remember that now? So that toString method is something that every single object, 100% of objects, are guaranteed to have, because 100% of objects inherit from the object class. Therefore, they get all the stuff that's built into the object class, including that very, very, very generic toString method that just returns a representation of the memory address that you could either take as is and do nothing with it, and then when you try to print out a superstring, you get the weird memory address, or you can decide you want to override that method and make your own more local version of it, a better version of it that prints something that's more appropriate for what you would expect the output to be for a superstring. Make sense? So that toString method is kind of it's an important aspect of object-oriented programming. So in this particular case, it's something that's specific to Java, but it's also a lesson in the inheritance model and how we can override methods that we get from our parent. Does that make sense? So toString method, certainly important for us, because would you say that when you create your own objects, it's going to be, it would be nice to be able to tell the println method to be able to print your objects out in some way that you have control over? Like, it's not always handy just to have it print out a memory address. All right, so certainly be comfortable with the toString method. I will probably ask a question involving that. I probably will not ask a question directly involving super, but you should be comfortable with it. It's kind of like this, but it's how an object refers to its parent from within itself. So this is similar to that question I asked before. Objects are collections of what? They're collections of fields, methods, constructors. That's what objects are collections of. The concept of coupling, I probably won't ask you a question about this. This is really more of a software engineering topic. But certainly when you write your programs, one thing you want to lean on is trying to make as many parts of your program stand on their own as possible, so that not too many of your moving pieces are reliant on other moving pieces of your program, where if one thing breaks, so do 5 other things. But we see that in real life, that's not always possible, right? Many problems that we solve are going to be at least somewhat reliant on other parts of that, that solution. So it's not like coupling is off limits, but we should try to minimize it. But at the same time, know that it will exist. The concept of exception handling, certainly, I could ask you a question about it, maybe a try catch or something like that, but it's pretty low on the totem pole. I think we have plenty of other stuff to discuss. So I would say I'd be surprised if I ask you something about exception handling directly. I could ask something maybe with try catches and what's the purpose of it. Kind of the idea of allowing a program to either recover from an error or crash more gracefully or something like that. But it would be low on my list. So I would study other things first. The loop keywords, certainly be familiar with these. How return makes a method immediately end and returns a value. The break keyword breaks you out of a loop completely. Doesn't break you out of a function, breaks you out of a loop. So no matter where in a loop you are, if you break, you move past the end of that loop. You don't move to the next line. You don't increment any more variables. The loop ends. And then what does the continue statement do? Next iteration through the loop, yeah. So continue says, okay, I'm done with this particular pass through the loop, but I'm not necessarily done with the loop. So let's continue on, where you basically skip the rest of the contents of the loop, zip back up, increment your counter, move to the Boolean expression, and go to the next time through the loop. So continue skips the rest of this iteration through the loop and moves on to the next iteration. So be familiar with those 3 things. So this quiz question that we had here, this would be a type of question that I would ask for like a programming question on the exam. Expect, several of those, 2 or 3 questions that are kind of in a similar ballpark to this. Writing kind of short methods that solve some problem. Whether it's manipulating a string or manipulating arrays or, yeah, I mean, typically at our level right now, that would be kind of our go-to moves for those things. Concept of recursion, you should understand what it is. There might be a question on there about recursion. I might, just as I'm kind of thinking about it right now, that might be represented in terms of I might show you a function that, and I might ask you, what does this function do? And I might write the function recursively. So you have to be able to follow recursion, something like that. So if it showed up on there, I would probably ask it in a question like that. I wouldn't put it high up on my list, but somewhere in the middle. And if I'm looking for a question, recursion would be something that I might try to come up with an interesting question around. But certainly understand that it's a function that's implemented in terms of itself, or more simply, it's a function that calls itself. We looked at the factorial problem as being an example of recursion, and more recently we were looking at merge sort as being an example of recursion. All right, so questions on the midterm? Anything you want me to go over that you're foggy on, that you want to talk about for a few minutes before we get out? Go ahead.
Is this presentation anywhere?
I think so. Copy the link. Let's put it on Slack. Should be able to click on that and it should pop up. Yeah.
Is it likely that you would ask us to write a sorting algorithm?
I would say it would be fair game, but I probably. So if you're asking me if it's likely, I would say no, it's not likely. And the real reason for that isn't because I don't think you should be able to do it, but it's more I'd rather ask 3 programming questions that make you solve different problems than regurgitate some algorithm, because I don't really expect you to memorize algorithms so much as be able to solve problems. So having you regurgitate an insertion sort doesn't really allow me to measure what I'm trying to measure. I want to see your competency in solving a problem kind of from your head rather than somebody who's invented some algorithm. So I would say don't expect that. If it existed on there, maybe I would show you code and say, what does this do? Something like that for you to be able to read the code. But really what I'm most interested in the exam is to see your ability to solve problems. So trying to give you problems that really should be in your wheelhouse at this point in the semester. So then you get to know when you come out of the exam whether they were truly in your wheelhouse or if they're a little bit too far out of reach at this point, which then tells you, okay, I'm a couple weeks behind or maybe more, but now you know you got some catching up to do so you can do better on the final and replace this crappy midterm score. All right, so I recognize that programming is fairly difficult, and that's why I give you that opportunity to fix a bad midterm, because it's going to happen. I mean, if you're not where you need to be, well, the midterm's not going to go well. But I also don't think one day should ruin your whole grade in a class. So now if you a whole bunch of days, maybe a whole bunch of days of crap should, but one day at the very least it should show you where you sit. Other questions? Anything you want me to review that you're not clear on? Going once, going twice. All right, I'll see everybody on Thursday. Don't forget to take advantage of the extra credit stuff tomorrow. Pretty important day, should be pretty educational. Even if you're not Christian, I think it could still be educational, because obviously here at Concordia you're surrounded by a whole lot of Christians. So at the very least, it'll help you understand what they believe.
What do you want me to do about
275 fund.